session about vegetation and the ecosystems one. And we have only 3 presentations today from 3 different countries: South Africa, China, and Australia. Maybe I'm going to give the floor to the first speaker, Mr. Maarten Jordaan from the University of South Africa, who is going to talk about the role of remote sensing for sustainable elephant management in South Africa.
Thank you. Unexpected to be first on the podium, but not a problem. Let's just get that done. I'm from the Department of Environmental Sciences, as you can see there, so it consists of other functions, not just remote sensing. We actually specialize in environmental sciences, so I have to explain where this all started for you to make sense of the presentation. So we also do conservation guidance and conservation management, and at one stage the conservation or reserve managers for a few of the reserves in Natal area in South Africa contacted us for some guidance as to how can they use remote sensing for the elephant management plans. I'll talk about the politics and the elephant management plans a little bit later in my presentation. But we went to the meeting where they had a meeting of all the reserves in the KwaZulu-Natal area. It's quite a few of them. Not all of them have elephants, but some of them do. And they had this terrible misconception about what remote sensing can do. To put that into perspective, it's a bunch of guys wearing khaki clothes like I do, much like what the Aussies will call the crocodile Dundee type. Very from the bush and so on, and they had this weird expectation. We got this from the meeting, that they can just push a button, like in the movies, the American movies, where you can follow cars and track down the number plates and all of that. That was their idea of remote sensing. So when we got there, their elephant management plan consisted of they'll use remote sensing to count the elephants, to check the damage that they cause. All of these will be done with remote sensing. So we had to bust their bubble a bit. Now listen, yes, remote sensing is this wonderful, big, powerful tool, but we're not yet at that level where you can do that. The Americans seem to, but we're not. So that's where it started. So our first project was to sort of, the aim is to give them an idea of the expectations that they can have with the role of remote sensing, its functions and capabilities, and the issues that they can really address. And in this, we sort of had to identify them. This is a process. You don't have satellite imagery already set up and ready to go, chopped off the shelf. You have to do a process. You have to either mosaic or subset your images to get your area that you want. You have to do some land cover classifications, some change detections if need be, and for elephants, that's the main focus. And then also the role of certain indexes, NDVIs and so on, and soil indexes. So they were quite keen on this after we've explained that there is limitations as well. And let's go back to the politics. In South Africa, if you don't come from South Africa or the African continent, you don't know about elephants. Maybe the Asians do a bit, but they don't have the wild ones like we do. So elephants are a bit of a problem, but their numbers are dwindling. And there's, according to the few sources, there's less than 700 African elephants left in Africa. I don't know about the ones in the zoos all over the rest of the world, but wild ones in Africa, there's less than 700. But in South Africa and in Southern Africa, the numbers are growing. And this is due to our very successful conservation projects. With these growing numbers of elephants, there's always an issue of human conflict. Elephants and humans don't go well together. So in South Africa we sort of solved this conflict issue by fencing them in to reserves. We call them reserves, and reserves are there to conserve them, so we fence them in, but these with electric fences, so we stop them from their normal migratory routes wherever they want to go, as well as from other natural resources. So our problem here is if you're fenced in and you only have so much to eat, you will eventually start, if your numbers go up, start destroying your habitat. Alright, so Loxodonta africana, which is the scientific species, there's two subspecies, the Africana africana, and then there's also the what we call the forest elephant in Africa, but they all fall under the same general term, and they are seriously running out of living space, and this is caused due to the fact that the African populations are growing, not elephants, humans, at I think is the fastest rate in the world at the moment. So there's a conflict between space for elephants and space for humans. And this leads to a dilemma, so you give them, the elephants, less space and the humans get more. And then the elephants also are a bit of a problem because they also damage their own environment. They're known for it. If they have lots of space, the system sort of sustains itself because they went off and go browse on other areas, so there shouldn't be too much damage. And then eventually they'll come back a couple of years later and the trees are back, grown to the extent of them, and the elephants can keep on sustaining themselves. But that doesn't happen if you fence them in. Right, to the politics again, the African elephant, because it is being poached and it's on the red data species list, it was a CITES 1 appendix species. But in South Africa, because the numbers are growing, we have it now being moved to CITES 2, so that means we can again trade in elephant tusks. Not that we do. There's not a lot of money in that anymore. The elephant itself is a unique character. It's one of the mega herbivores. There's only a few of them. It's elephants and the hippos, the rhinos and the giraffe are the mega herbivores. And why they call that is because of their eating habits. They drink 200 liters of water a day, plus minus. They are water dependent, so they try to stick as close to water as possible. They also consume an average 170 kilograms of leaves and twigs and grass, etc. The big bulls go way beyond that, over 200 kilograms of grass. And they are labeled a keystone species in that they can have an impact on the ecosystem and modify the system. There's lots of areas and research been done, especially in Kenya and up there in Africa, where they have actually destroyed the forested areas and had it changed into grasslands and so on. So they are a species that have a serious impact on the environment. They do have, I'll talk about the elephant herbivory just now, but they do have a preference for certain species, plant species, and I've listed a few there that was identified by researchers in the areas that I'm going to speak about. So lots of acacias there, so you can see that these guys don't matter. Only one without thorns is the marula tree. The rest has all got serious thorns, but they don't mind that. Apparently it tastes nice. So this is the eating habits, and the elephant is a bit of a barbaric eater when it gets to, as you can see, they tend to demolish whatever they eat. They've got some breaking the branches and debarking it. They quite like to bark, so wherever they go, you will see some of these damages occur. And these lead to the destruction of the trees. I had a little video, but I had to take it out on what happens if a male bull elephant goes into what we call must. They are, I'll tell you about must. Who's not an elephant expert here? Nobody. Alright, what happens is this male elephants, the bulls don't walk with the females. If you see a big herd of elephants, that's females and young. They form the herds. There's one female that takes over and is the matriarch of the herd, and they go as they want, mostly close to the rivers and so on. The big bull elephants tend to be loners, they walk off and go where they want, break the place, and then when they go into must, which is then what we call mating season, luckily it doesn't happen too often, they then go and find the female herds. So in the process of the female herds, they first have to test their strengths to see how many females they actually can go. Anyway, so they test their strengths, and how they do this is they choose a tree, usually a nice big one, and then they tend to see if they can push it over. And they push over big trees, reasonably thick marula trees like this, no problem. Just walk to it, push it over, and then end of that marula tree. And if he thinks he's not strong enough, then he'll try another one, and so he goes on until he gets to the females and uses up his energy and luckily on other ways. So that's one of the main destructions of some of the trees. Okay, let's go back to the politics. In South Africa, because of the numbers growing and animal conservation specialists having a big issue about culling, the numbers in Kruger National Park, the KNP there is Kruger National Park, which is our South Africans' nice and big reserve. If you haven't been there, please come and see it. Before the elephants destroy it completely. They had a strategy of carrying capacity. So back in the 1960s, 70s, they said 6,000 elephants, that's it, no more. Then the culling was stopped because of these pressures being put on them. So they didn't cull anymore. So the second process was to ship these elephants out to other reserves. Where there's a small reserve that wants an elephant, you can have them for free. Please take some elephants. But the numbers were still based 6,000 to 7,000 for the Kruger National Park, which is quite a big area. Then all the other reserves that were willing to take elephants were full, and they had other problems. So they changed their strategies. They said, all right, no more carrying capacity. We now have this new process of where we'll see what the amount of impact is on the ecosystem, and it shouldn't go beyond this. And that's their new strategy, which led to the fact that there's now 13,000 elephants in Kruger, and they are causing havoc. It's more than double the numbers initially stated by the same experts. Anyway, this led to the then Minister, we call him Kortbroek van Schalkwyk, with short pants van Schalkwyk, and he said every person in South Africa that's the owner or manager of an elephant should have an elephant management plan. This plan consisted of how you're going to manage your elephants with regards to preserving the systems as well as controlling the elephant numbers. Right, I'll talk a bit about controlling the numbers, but before we get there, this led to the fact that all elephant reserves have to have the elephant management plans, which led to us being contacted and said, please come and help us with remote sensing on this elephant management plan. And they need to know what is the optimum size of the population for the elephants in that specific reserve, because all the reserves are set and fenced in. What is the growth rates, as well as what is the carrying capacity, and that's where the remote sensing part comes in. Each reserve, and I'm going to show you 4 reserves that I selected, has got different objectives, and I'll talk about the objectives when I show it. Right, the role of remote sensing. There was a study done by a colleague of mine from the Pretoria University that did sample and of all the conservation managers. These are guys that are supposed to be experts in the field. They viewed science and specifically remote sensing as an essential tool for the development of the elephant management plans. In other words, they clued up. They know they have to use some technology to look at the environment, and they clued up enough to it. 99% of them, I don't know who the 1% is, I really need to find out. There's 1% that doesn't think science and technology is necessary. Anyway, so they want to use satellite imagery to do a classification of the vegetation types, to do change detection in biodiversity change detection with regards to species richness. That means that if you have a lot of different tree species, and elephants come in and they browse off half of the acacias, or in one case, I'll show you the Welgevonden one, all the acacias, that's an impact on the species richness. Changes that have occurred over time is a change from woody to grasslands, etc. Refugia is where some of these got endangered red data species, where there's places where they can hide, and not looking plant species specifically, and not be impacted on by the elephants. And what is the carrying capacity and carbon sink potential for the specific reserve? The 4 areas that I've identified, and the first question should be, why not Kruger National Park? And that's easy. Everybody researches Kruger National Park. Even the Americans, the people from Finland and Norway, and as far as even Australia, I assume, I don't know. But everybody is researching Kruger National Park, so we've decided to focus on the smaller reserves because they don't get any attention. Nobody even looks at their impacts and so on. So we've looked at 4 of them. And if you can see, I've identified in our South Africa, there is the northern KwaZulu-Natal area. There's quite a few reserves there with elephants. I've chosen Tembe Elephant Park over there. You can see that's Tembe over there. And then you have Itala, which is up in the mountain area in KwaZulu-Natal. Not really up in the berg. That's Itala over there. It's near the Pongola River. It's quite a nice and scenic one. And then in the northern province, I've chosen Welgevonden and Marakele. And each one of these are unique, but there's similarities, and that's why I chose these specific 4, because of their similarities. They are similar in size, plus minus 300 square kilometers in size. That's what we call medium-sized. Medium size is from 250 to 500. Anything above that is large. They all have plus minus 100 elephants or more. Not a lot more, just above 100 when they started off. And they also have been inhabited by these elephants since 1990s. So there was time for impact to have occurred. Most of the elephants that we talk about come from Kruger, except for the Tembe elephant. The Tembe elephant is quite unique, and it's the one that's been fenced in due to the wars in Mozambique, just across the border there. So they fenced in the Tembe elephant to protect them from being slaughtered by the indigenous people from Mozambique just across the border, because they didn't have food. They were at war for more than 20 years. So they slaughtered the elephants for food. So we decided to fence them in, at least some of them, to protect them from this. Right, so the rest is all being shipped out from Kruger to these reserves since 1990. And that is why I've selected these specific reserves. They also have very similar vegetation types. So these plant species that I've identified occur in all of them, and makes it quite easy to compare the results. Right, wrong way. That way. Yeah, right. My first one, Tembe. That's the one that is, it's a private reserve, but it's run by the provincial government. It belongs to the local tribe, the Tembe tribe, and it's quite spectacular to visit. But remember, the elephants there is a bit more dangerous than others. I mean, in Kruger, you can drive up close to the elephants. I wouldn't dare it if I were you in Tembe, because they've been hunted and they remember quite well. Everybody talks about the memory of an elephant. It remembers it very well. And if you drive a Wit SUV or a white SUV or a what we call a pickup truck, you are in serious danger. They remember those exceptionally well, and they will attack you straight off, as I can vouch. You can see the sand forest area is quite a thick, dense clumps of sand forest, and that's the main concern for tourism. Everybody thinks that Tembe Elephant Park is there to protect elephants. The elephant is the second priority. The first priority is to protect the indigenous sand forest, which is endemic to that specific East Coast area. The second priority is the elephants, and then thirdly is this little antelope down there. It's called the Sunni, and it's on the red data species, so it's very important for them to protect that as well. Right, the next one is Itala, which is a public one, belongs to the provincial government. It's quite scenic, it's in the mountainous areas, which is a challenge for when you do remote sensing. It's been a reserve from 1982, it's quite a long time to be preserved, and it's nice and scenic. As you can see in the bottom tutorial, it's hilly, but it's not too bad. It's not as on the one side of the steep cliff, and that's luckily it's on the end of the reserve. Makes it very difficult to do remote sensing on that. Their priority is to preserve the natural biodiversity, in other words, all animals. So if the elephants take over, they have to make a plan with the elephants to preserve the other species, because not one species gets preference. And they also have some red data species, which are listed there. And they also have, which is quite endangered species at the moment, some black rhino and white rhino, as well as some tsetse and wallaby antelopes. Alright, my third one is Marakele, and it used to be called Kransberg in Afrikaans, and in English is Cliff Mountain Reserve, which is aptly named because it's got these cliffs. It's much higher away from the ocean, but the vegetation types is reasonably the same. They also are a national park, in other words, the national government is the custodians, and they also have to preserve the biodiversity in total, so not one single species gets preference. And it's also one of the few that has the big five, which I'll get to now. Belgevonden, just a neighbor of Marakele, they're quite close to each other, is a private reserve owned partially or mostly by foreigners, which have put up these luxury lodges. You go stay there, $5,000 a night easily. They fly you in with these luxury jets, and they land there, and their main concern is to provide their customers, which is all Americans, who's American here, for the money to give them a Big Five experience. So if I talk about Big Five, I don't know who's not knowledgeable about the Big Five. It's the lions and leopards and elephants and rhinos, specifically black rhino, not the white rhino so much. And buffalo. Those are the Big Five. So if there's less trees, so the elephants do them a favor, push over the trees so then they can see these Big Five animals much easier. But they give you a very close and hands-on experience of how close you can get to them. So if you have money, you can go stay there and you can experience the Big Five very up close. But they also are part of the bigger Waterberg biome, which Marakele is also part of, and they at least have to try and preserve the natural system as much as possible. Right, the rationale for the study was to inform these conservation managers of the four specific that I mentioned, of what they can do and what they can't do. Specifically mentioned their limitations for satellite imagery, as they really thought that you can read number plates and so on. I think they watch too much movies down there. So what I did was I used Landsat in 5 and 7 images, as well as Spot 4 and 5, and a bit of QuickBird just to do some referencing. For each of the reserves, the QuickBird was just there to reference and to verify. The people in this reserve don't have a lot of money in their budgets to buy satellite images. So we have to keep it as cheap as possible, because this is a trial run for them as to show them what it can be done. So if they have to buy satellite images, and I'm talking about high definition or high resolution, they won't be able to afford it. Not regularly anyway. So they have to, on a regular basis, see the whole extent of the reserve, and that's the role of remote sensing, because that's what we advertise. Remote sensing can be used to see the total extent without you having to go drive around in your 4x4 to see what the impact is. And we did some, the first image that we acquired was from when the elephants were first introduced, and then every 10 years. We're in the process of doing it every second year. but the images are not so easily to come by. It's quite cloudy. Some days you get images that's full of cloud and it's useless, so every second here didn't work out. So we're working on that as well. And then we do change detections and NDVIs and image classifications for each one of the reserves on each one of the data sets, Landsat as well as Spot. And we showed the reserve managers these maps that we've created, the NDVI and change detection maps. And for us, it didn't make sense. But the moment you put it in his hands and you look at it, immediately the eyes open and say, oh, this is nice. And they were quite chuffed with what we did. There's some NDVI that we did from Welgevonden. I use Welgevonden as an example for 1995 image compared to the NDVI of the 2005, so a 10-year difference. And you can see, look at there, you can see there's some areas, darker areas, which means that there's less vegetation. So there is some impact that can be identified. We also did a change detection using normal AMDAS software to do some change detections. We identified 25% as a base to which to, below that it could be climate or any other changes, but above 25%, according to the specialist, it could be impact created by the elephants specifically. So these show the impacts. If the first one is the change detection using the NDVI images, and the second one is we use your normal band combinations, specifically the infrared